The first thing we'll do here is we'll write out the complete equation. So we're starting with sodium hydroxide, and we're combining that solution with iron 3 nitrate. And when we swap the ions, we're going to get iron 3 hydroxide and sodium nitrate. And then when we balance, we're going to need a 3 here, and we're also going to need a 3 over here. Alright, so that's the complete equation. If we cancel out everything that is soluble, then the equation we end up with is iron 3 plus, 3 OH minus ions, and iron 3 hydroxide, which is a solid. So what I did there, I didn't really go into the details of it, but if I know that all the alkali metals are soluble and all nitrates are soluble, so I know everything there is soluble, so that means that this has to be the precipitate, and I also know that transition metal ions for the most part are going to be insoluble. Sorry, transition metal hydroxides are going to be insoluble. For the second part of the problem, we're told that we're going to get 0.886 grams of the precipitate, so I can write that down, 0.886 grams, and the precipitate is iron 3 hydroxide. And we want to know the volume of an iron 3 nitrate solution. So this is a little different than the way the book shows it. It amounts to the same thing, but I think it's a little bit more straightforward. So I see the relationship between, up here, between the iron 3 hydroxide and over here, the iron 3 nitrate, and I'm just going to use that. Alright, so that's basically a 1-to-1 ratio. So I guess first I need to do this. So I need to convert the iron 3 hydroxide into moles, and that mass is about 106.87 grams, right? And then there's 1 mole iron 3 hydroxide for every 1 mole FeNO3, taken 3 times. And now I'm given up here the molarity of the iron 3 nitrate. So I know that when it says 0.136 molar, that means 0.136 moles per liter. So now I'm going to use that information. So I'm not going to do that, but down here I'm going to put 0.136 moles, and that's iron 3 nitrate, per 1 liter. Alright, so when I do that, everything is going to cancel except for the liters, and when I multiply through, I'll get that the volume that I need is 0.0610 liters. Okay, so now I want to look at the second part of the, or actually the third part of the problem. And for this part, it's a little tricky because I've got up here the molarity and volume of the sodium hydroxide solution, and here I've got the molarity and the volume of the iron 3 nitrate. So I'm going to clear out some of this information and then start again. For this part of the problem, what we're doing is using some of the ideas that we learned toward the end of Chapter 3, plus the ideas that we already had developed about molarity, and we're going to put those together in order to answer the question. So you always want to start with a situation where you can get moles. So in order to do that, I'm going to take the 50 milliliters, and that's 0.050 liters, and the concentration of the sodium hydroxide is 0.2 molar, so that's 0.2 moles sodium hydroxide per liter. All right. For every 3 moles of sodium hydroxide, I get 1 mole of iron 3 hydroxide. And then finally, a mole of iron 3 hydroxide is 106.87. Okay, and then I go through and I do essentially the same kind of operation, but this time I work with the iron 3 nitrate. So for that I have 0.030 liters. The molarity is 0.125. This is moles iron 3 nitrate per liter. And for every 1 mole iron 3 nitrate, I get 1 mole of iron 3 hydroxide. And again, this is 1 mole, and it's 106.87. Alright, so I'm just going to pause for a second and multiply these out. So when we multiply through, we get that we could make 0.356 grams of the iron 3 hydroxide, that's up there, starting with the 0.050 liters of 0.2 molar sodium hydroxide, and if we started with the iron nitrate, we could make 0.401. So just like we learned in the last chapter, the one that will make the smallest number of grams is going to be the limiting reactant, and the amount that that makes is the theoretical yield. So we could make 0.356 grams. So it's a little bit more involved when we have solutions. There's kind of an extra step that we have to use, but the concept is the same. We're starting with both of the reactants, and we're finding out which one will make the smaller number, and then that's telling us what the theoretical yield is.